PhD, slightly different. Dual degree PhD from IIT Kanpur and bachelor's from NIT Warangal. He is going to talk today about aerosols and the effects that aerosols have on climate. Thank you, sir.
Thank you very much for this opportunity. And I see some known faces and many unknown faces. I think by the time I end this, we will be interacting more and I will be knowing. Uh, Most of the work that I will talk about has got fundings from these institutes, and I am very lucky to be somehow related to all of them, either by proposals or I'm alumnus of many of them. Uh, and this photo. So, wanted to start with this image because I believe this image turned me from civil engineer to atmospheric scientist. Sometime in my when I just joined IIT Kanpur, at that time I came. So Professor Ramswamy from GFDL Princeton was visiting IIT Kanpur. This image he showed, and he was discussing mostly at that time about global models of and how atmospheric chemistry is changing the Indian monsoon. He gave a presentation, and somehow this was discussed. What I want to highlight is this is I believed he mentioned just at the border of Bangladesh, and this is the tributaries of Hooghly and other rivers, and uh, he presented and went off. I was really excited about the cloud structures present here. I can see a tower here. I can see a tower and an anvil which is coming out. Then there are small clouds forming and the entire convective system. So when we just look up at the sky, it's we start. There are many things that you see, but I never thought clouds could have such a very different structures. And from there, I was interested into atmospheric science, and somehow because I am linked with civil engineering, environmental engineering, air pollution, and atmospheric science. So most of the things I will talk today are interface of all these things, and I diversify more as I go into the field. To start with, what I want to talk today is how all these things are related to our regional climate change. So this is an assessment report by Ministry of Earth Science, which came out 2020, and they have given some values here, right? Uh, so when we say climate change, it is a phenomena, but we want to measure it, right? Some of the key variables that we are measuring or are able to measure are precipitation and temperature. So climate change is generally the intensity is talked about in temperature and pressure, and you can see this is the abstract figure of that assessment and what they are talking about. Three main things. Hindu Kush Himalaya is a region which is very susceptible. There is a clear change in precipitation. These are all projected, right? This is not real yet. They are projecting into future with the best understanding of numerical models we have, right? Temperature changes you can see it in the order of 3-5 degrees. Like if the worst scenario is there, there will be 5 degree change in next 50 years, right? Within 50 years, 5 degree change. The top is Himalayas, which is a very unique natural resource in India, because many times we tend to call it as the third pole also. We have two poles, a lot of frozen hydro in there, and then we have this Himalayas, which has highest number of glaciers out of these poles. Uh, Second is the monsoon. We are tending to see 20 I think percentage 20, around 20% of change can happen in our monsoon. When we say monsoon, it can be total amount of rainfall, it can be the number of days it is drought in the country. That also comes under the purview of monsoon when we talk about the total number of thunderstorms Chennai will face in 20 years from now. All these comes under the precipitation, the intensity, frequency, and duration. These are the terms in which we are talking about precipitation, and there will be some change projected. And then surface temperature in ocean and surface temperature in land. These are the key important things we or as a nation we believe regionally we are changing, the climate will be changing, there are some projections, and this is very different from the global climate change projections, the values. And hence nowadays, or let's say in last 3 to 4 years, there is a tendency to focus more on regional things, regional climate change compared to global climate change, which was the focus in last decade. There are two reasons in that. First, we understand greenhouse gases are the cause of global change, and suddenly the greenhouse gas is not going to go away, even if we make important changes. There are short-lived climate forces which are affecting the climate change, and these are totally regional. And one of the main climate forces is aerosol, and we'll come to that. And I am also curious how to put down this LULC changes, more urbanization, crop forest to crop to barren land. These changes should also be somehow short-lived climate forces or mid-lived climate forces and somehow affecting, but it is still not defined very properly in IPCC. So I've just kept it, but this is also some area of interest I want to know. And what what I'm what are we trying to do? These are projected by models. We want to better represent these forces in the model so that the projections is accurate. That's the entire goal of this field, right? And to know that we do a lot of measurements. We want to understand how are the processes, how are the feedbacks, can we parameterize them, can we put back them into the model, and can we improve it. And it might seem it's a very long shot, but we have improved a lot in last 20 years. That's the same.
Sorry, what is LULC?
Land use, land cover changes in Earth's surface. I think I'm going slow, but I think I'm enjoying talking more. So just I might stop somewhere in between, but I would like to show. When I say aerosol, I wanted to visualize what I actually want you to see. This is an image from 2 months ago. I was flying back from Delhi to Chennai, and what I saw was actually very panicking to me. So blue skies can never be seen for a Delhiite, and they could see it in COVID period, and it was big newspaper headlines. And at that time, I was not, I was just joining here, so I was not that much concerned. But from plane, I can see blue skies, but they can never see blue skies because of this layer. Delhi. Because of this layer, you can see this gray layer. I, I, I have been in Kanpur and that region till 2016. I have not seen such layers. So something has changed in last 10 years, just last 10 years. And now these layers are present. And these are, you can imagine 1.5 to 2 kilometer in height, right? So someone staying in this house in fourth floor can never look up and see those blue skies. Everything is getting scattered. Right? This is just to visualize, right? And this is while I am landing back into my native place in Odisha, quite unurbanized. Right, this is somewhere near Ranchi airport. I was landing back. It's same. So the entire North India is seeing this. It may be dramatized because of winter effects. It was November and October that time, but nevertheless, this will be diluted up to this height. This is there. This is what you are emitting. Hence, what you are emitting is definitely going to change your atmosphere and your climate. We need to understand this. And this has been very clearly acknowledged by IPCC since last 10 years. Aerosols are the biggest uncertainty in our climate understanding. We need to better understand different interactions. They have highlighted this aerosol cloud radiation interaction. Uh, I have introduced some terms, and I think this is self-explanatory by this time. We have different systems: mesoscale cloud systems, extreme rain. This, and then on a larger scale, we have hydroclimate cycles. We have radiation cycles uh, that is linked through different land cover systems. Snow is there. Simple hydrology, water is there, and all of these are connected through atmospheric processes, and hence aerosol has to be playing a role in it. And since last 20 years, this atmospheric community is trying to better understand this. We generally use atmospheric models. We do simulations without without these short-lived forces, let's say urbanization or atmosphere, or one land use land cover change, or including a better parameterization. These are the sensitivity experiments we do. That experiments are informed nowadays by a lot of remote sensing, with, like the way I show you a picture from flight. We can see many pictures from satellite. We are also getting a lot of understanding. I will show, I use it in my studies. Large scale aircraft campaign and ground based remote sensing. These are monitoring is something you can understand. Atmosphere is 30 kilometer in its stretch over the entire globe. So it's 3D and very dynamic. So what you monitor over Adyar may change as soon as you go to a 5 kilometer into the city and 10 kilometer out of the city, right? Uh, what things are common, what are not common, at what height all these things changes, what is the blending height? These are questions we still don't know, and lot of monitoring is needed. But overall, in last 10-20 years, lot of computational power has gained, technology has improved, satellite have. So when I started my PhD, satellite were giving data at 100 kilometer resolution. Now it's 1 kilometer resolution. uh, we as a team, my team now is also creating a remote sensing sensor in lab, which was unthinkable 15 years ago. So everything is changing, computational. Every lab has now computational power. So we are, and towards the end I will show these are also opening up new complexities, but nevertheless these are all positive things. uh, what are aerosols? Just a few images to visualize what you cannot see by your eyes, right? uh, Aerosol as a term is a very complex mixture of many of these species, which are either naturally emitted, like dust, biogenic emissions from plants, or it is anthropogenically emitted from all the fossil fuel burning activities we do. And these, and sea salt is also a natural emitted particle. These are very different in terms of morphology, shape, and color. And color is very important because it indicates their relation with radiation. So if a black color stuff is there, it will absorb all the radiation that comes to it. If a white color stuff is there, it will scatter all the radiation that is coming to it. And you can imagine, like, if in this room there are certain things which can absorb temperature, it will warm up this room. If it can scatter it, then your energy stored is less. From this was the basis of understanding, and it's since 2000 we have started including a lot of radiative aerosol radiation properties in our global models. What we generally do, uh, we take a particular aerosol species, we experiment in lab, we find out what is the radiation coefficients. If you scatter, if you incident light on it, how much it will absorb, how much it will scatter. You take those properties and project it in your models. You have radiation coming in from solar system, you have the radiative transfer models. You now include these particles or properties at different layers as per your understanding, and that will automatically change the amount of radiation that is reaching surface, and vice versa. It has been seen that it, and the community was highly excited to see the results from 2005 to 2010. Almost every paper was something no one imagined. No, you cannot see these particles. At that time they were less, and once you put it them in global models, you started seeing that systems, such complex systems like Indian monsoon, is totally changed, right? When I it's totally changed is the dramatization, but more than expected, it's changed, right? uh, this is a paper from 2010, which, like, after 2 to 3 years of lot of publications, it was published in Science, and it clearly explains that the decrease in rainfall, which was seen from 2000 to 2020, sorry, 1980 to 2000 period, there was a steep decrease in rainfall over Indian monsoon region. And if you put aerosol or you remove aerosol from your global models, it starts explaining that trend. And everyone was so excited about it. But I will say that in last 20 years it has again changed. ISMR is now increasing. So just just trying to say that it is just one process which was explaining them, and as we go I will keep on introducing new processes that we learn in last 20 years, and the net result of rainfall is inclusion of all those processes, right? Next, uh, as computational power increased, we started reducing our models and we could simulate cloud scale features. Right? Cloud scale means 5 kilometer, 10 kilometer. Clouds are formed at 5 kilometer, 10 kilometer. This is the time when lot of measurements of cloud droplets started happening, flight measurements, and we started seeing that if it is a polluted environment, the number concentration of cloud drop is definitely high. This is from different regions of the globe, and this relation started to appear. And this is known as the first indirect. I forgot first indirect effect or impact. But what it talks about is aerosols can affect the cloud droplet concentration. At the same time, these droplet concentration, like if it is a clean place, the size of cloud droplets are bigger compared to the size of cloud droplets which are present in a polluted atmosphere. So at one instant it is decreasing the size, at another instant it's increasing the concentration. These are the two basic changes which can be seen, or we understood what happens in a clean versus polluted cases. However, again from 2005 till 2018, there is an array of studies on this topic, and more complexity started coming into picture when we include the convection also. Like when I say convection on meteorology, winds are there. The first set of results are, you can think like a box model. Within the room it is done, you put more aerosol, what is happening. But once you open up the box, there is dynamics. Turbulence is creating your parcel to rise up. Winds are there to shear your cloud. All those dynamics when you bring into picture, then there are different things that started to appear. There is a famous line of research from which has been constantly being published in very reputed journals, and it says that if you increase the pollution, or if the region is getting polluted, right, the clouds are getting the droplets are smaller, and hence its buoyancy is decreasing. So what will happen? It will go up in atmosphere, and the liquid will turn into ice if it crosses your freezing level. Once it becomes ice, it will fall down at a very high speed. So what type of the understanding is, if a storm has to create rain in 3 hours, now it is delayed. The first 2 hours there is no rain because everything is going up, the droplets are smaller, and in the last 1 hour there is very heavy rain. All the mass is coming down, and this can create these kind of thunderstorms are increasing the extreme rainfall and trying to explain. Right? At the same time, there has been papers at similarly highly studied groups and big journals which says that this is not true every time. There could be buffered systems, a lot of different systems. Our system is a monsoon convection system. The American system might be different. Australian system might be different, and we need to understand it much better. Uh, at this point also, every lab who works on this are doing very specific experiments, and we are seeing new results where small meteorological factors like wind shear. This month only one good paper has been published which says wind shear is dominating the cloud structure over marine regions. Now, interesting to say, we have just discussed if aerosols are there, it can change the wind circulation and wind shear. So it opens up another line of research. Are aerosols also affecting wind shear and hence getting the clouds affected, right? So these are the basic. What I talked up till here are the basic understanding of this field. Aerosols can affect by radiation, aerosols can affect by cloud. And as you can understand, if there is a lot of cloud, it will affect the radiation again. And it can affect the precipitation and temperature. The regional changes that we measure are in terms of precipitation and temperature. If you don't have this effect, all your estimates could be way off, overestimated as well as underestimated. Hence, we need to understand this, parameterize this better, put them back into the models, and then the projections, then we will start seeing more better projections. The rest part of it, I will introduce, or I will just talk about two of my papers, which I think are very interesting to me, and show how we try to have an understanding of aerosols, how they're affecting over India. So this was a question which uh, so people talked about aerosol can change the distribution and rainfall pattern. And you remember the first figure, right? Which I was very enchanted by the cloud structure. So I thought I start asking, can the cloud structure itself be changing? And there are some satellite studies before I started working on this, which says talks about anvil versus tower relationships. Uh, to better understand what I am trying to talk, I will discuss about this result. This is during my PhD time, and we did a radio sound campaign in Kanpur, IIT Kanpur, and our aim was, or this was, I still remember the discussion. What is the cloud base? We see the clouds, but what is the base at which we see it? And we didn't have any measurement. What we see from satellite is all top of cloud. So we we, we did this, and interestingly, we can see that. So these blue lines are single clouds. From radio source, we calculate back what are the cloud layers by calculating the differentials of relative humidity. It changes, right? Uh, these blue lines are the are, or everything is cloud layers. You can think blue are the single layers. So when you release a radio sound, you approach a layer, and it keeps on going, and after that there is no cloud layer detected. And you can think it as a tower in that image, right? The entire region, let's say 5 kilometer by 5 kilometer, had a tower convection on that day, and the radio sound flew in between it and measured it. And then there, and you can, and this axis is rainfall. If you look back on all those heavy blue line days, there happened rainfall, which is quite obvious. Like if you have this much big towers convection, you will have a rainfall on that day. Then there are many days. Just think it, you are standing in one position and releasing it every day. So it doesn't happen that it rains every day in that position. There might be clouds. There are a lot of days where you see anvils. But what do you mean by anvils? When a tower is formed, and then it will expand out because of atmospheric, some thermal gradient, and you see a lot of anvils throughout the month. This is month of August, when there is a lot of monsoon convection. This was very interesting to see. It means that the convections are not happening within a very short region. It is happening at a much more regional scale, right? If I go and we checked with satellite data, and we could see that our convections or mesoscale systems were 1,000 to 2,000 kilometer in a square area. So, so it means that if it rained over Patna, the next day you can see anvils over Kanpur. If the wind is blowing from Bay of Bengal to Himalaya, that's some kind of thing we started to look at, and this is more than what we believed. This much of anvil present for 1 or 2 days and going is something new. With this understanding, we went back and checked satellite over this entire region. Right. What we did is NT is towers. So from satellites, you get small pixels of 10 kilometer by 10 kilometer box. If it is entirely covered, and as you remember the blue lines, if they are very thick, you can see the optical depth from satellite. You will understand which is a tower and which is an anvil. So tower and then anvil. If you divide every pixel into a tower and anvil, and act is as a function of pollution, AOD is pollution, you start seeing that anvils are increasing as the region is getting polluted. Tower formation is changing into anvil formation. This is observation from satellite. First we did it from measurement, now from satellite. Uh, why this is happening? To know that, we did high resolution regional scale modeling. As I said, you can include aerosol and you can not include aerosol, do the entire simulation and compare what are the changes, simulation of the entire world. Our hypothesis was uh, aerosols are changing or lifting all of this up, and there is something happening around 10 to 8 kilometers which is shearing all these clouds, and anvils are increasing. Effectively, uh, I will not go into much detail. This is the difference plot, and uh, y-axis is height, x-axis is thickness. In a simulation, you can always know the thickness of your cloud layer, and if you take a difference, and this is the region of tower because the thickness will be very high and your cloud top will be also very high. It's the thick cloud and the top of the cloud is very high. And anvils are which thickness is low but top is very high, right? Tower and then anvil. And it started to look that anvils are increasing if you increase the aerosol. And what was the cause? We have a easterly jet flow at 8 to 9 kilometer over North India during monsoon. Because of this, more water is drawn up, and there is a strong force there which shears it away, right? And hence the cloud structure starts to change. What is the implication of this on all this regional cloud climate change we are talking about? The model shows if such a scenario is simulated for 1 month of that monsoon, with and without aerosol, there could be a temperature difference of 1 degree over that Indian ISM. I showed you the region, right? Over this entire box, that is our monsoon box. Just remember, our projected temperature is 4 degree, 5 degree. If this is the uncertainty, we are we are somehow 20% uncertain about a simple temperature thing, right? I have a video. How much time I have, or I should rush? We have time.
This 1 degree will be cooling or warming?
Cooling, because so anvils, when anvils are formed, they stay there for long because towers are such that they will form ice and fall down. But once sheared out, the particles will even grow smaller because of radiative effect, and the cloud coverage will increase definitely. So this was a video which I showed everyone, which summarizes everything that I am talking about and from my initial work. So once you have more pollution, these droplets start decreasing and go higher up in your atmosphere. And after, as they crosses the freezing line, it becomes icy or big particles and fall down. At the same time, if they cross 10 or 12 degree, 12 kilometer altitude, the structure starts changing. So what you are seeing is at somehow the rainfall frequency is changing, the cloud structure is changing, and it is affecting both of your measurements of relative climate change, precipitation as well as temperature. Another question I worked on in my postdoc mostly. So we have all these absorbing particles in atmosphere. Eventually, these are short-lived, but it means that it will come down at a day at 7 to 10 days. Eventually, it will settle down somewhere. So what we emit in North India, that whole bunch layer, somehow is also going interacting with Himalayan snow. Snow is a surface which has very high albedo, close to 1. So if you put a little bit of particles of that, and I will show images to confirm this, the change in the surface energy is quite high. Come to this, I want to show this first. Yeah. So this is from just before. Uh, this is not COVID year. This is 2019. Okay, so February, March, April, May, June, July, and if you have gone to Manali, you know this is Manali. So Delhi is somewhere here, and you have this stretch here. This is Manali. This is Dalhousie, those that place, and you can see from February to May and June, the color of snow starts decreasing, and there is no other atmospheric change which is happening. So snowfall stops around somewhere in March, and after that we are all waiting for the snow melt to happen and go away. While if you are at a hilltop, the snow melt is happening, there is no reason why you will start seeing it darker. One condition is that the snow particles may be bigger and they can change the satellite images. These are satellite images, but this is also a potential find a potential link that atmospheric depositions could be higher. Now, there has been a lot of studies which actually says how our snow mass trends are changing over Himalayan, and it is all negative, right? It is all negative. This is the percentage of snow cover in different basins over India, and this is the rate at which it is decreasing. What is interesting is that this uh, black and red. So black is Amu Darya and red is Indus. So that is the Indus basin, and Amu Darya I think is 2, right? Those two regions are showing a very different trend with height. Y-axis is height, x-axis is the rate at which it is decreasing. There is a parabolic shape decrease, which doesn't make sense because all of the elevational changes are same. This is a paper published in 2018 by Science Advances. At the time I just joined in my postdoc, and this is something which where I started to link with the work we have done in India. Right, in India we could clearly see this is the pollution load that you see over India. This is the that layer, right, what we showed, and it is very prominent over North India. In pre-monsoon period, May, June, July, August, the winds are westerlies. So all these pollution is blown to our Himalayan region, and this is the lidar-based measurement of pollution. Right, that layer we have measured by lidar, and we see a parabolic shape structure quite clearly around 3.5. This was what I did in my PhD time, and when I saw that, I started asking, can these two be linked, right? And to know that till that time in models we didn't have uh, a module where the atmospheric deposition can go into the snow and change it. So that's uh, these are some images to uh, like closed up images to convince you. What you see is this is dust deposition. You can take some black carbon with you shoot and deposit it, and if you leave it there, right, for only 2 hours, you go while you are trekking, you put something, while you come back, you measure, you will see a depth, hollow stretch. What it means is snow melt is accelerated over that region. These are just to motivate. And so we so there are snow models which take albedo and calculate how much snow is melted. There is atmospheric models which simulate the emission and what is the concentration in atmosphere. The coupling was still not present in high resolution models. In my postdoc, I worked on this. We coupled it to know if so, because in models we need to have with and without some cofactor. So once we couple it, we can do two simulations, one with dust and one without dust, and see the difference. Is it actually creating a difference? So this is a model evaluation after we did it. This is a satellite-based estimate of the change in albedo because of any darkening. Those kind of images I saw February, March, April, May, June. Some estimate out of those visually, and this is our modeled part. And we started seeing that it is not very bad. The coupling and everything looks good. Based on that, when we simulated, right, we can separate out the albedo change because of black carbon. We can separate out the albedo change because of dust, and we started to see that dust actually creates this kind of parabolic shape in that Indus Valley. And this, without this, you cannot explain, or can again, like, because we didn't do a simulation for 20 years to talk about the trend, but a process. this process, if we include and run it for 20 years, might show that the snow melt trend, which is very high in 2 to 3 kilometer, could be because of this. Uh, and yeah, means this was something interesting and got appreciated, so I showed it. And then based on that, presently after joining here, I am doing a lot of 2 years. I am going up to there because we don't have lot of measurement of dust. All the things that we talk about is from satellite. So actually, what is there? This is a filter paper which shows how black it can be just after uh, filtering it out. So we have been there. My students are working their PhD on it. We are doing measurements, and this is near Manali. We have atmospheric measurement equipments, and then we are also taking snow samples and trying to correlate what is there in atmosphere and snow, and are the models doing it correctly, just to improve it more. Some more. I'm collaborating with different people because those are very logistically challenging places. So this is the first one was a thing at Himachal Pradesh. This is at Kashmir. So I collaborated with the University of Kashmir, and they extended the hospitality. I went to glacier for first time. I've always seen glacier by pictures. So we were at 4.8 kilometer altitude, which was very exciting. We did sampling, and we are working on it. There are some other diversifications which I am working on recently, and we are talking about aerosol uh, radiation and cloud processes. If we bring down the scale to urban, right, how are they changing? This is also a question. Presently, I am working with very high resolution simulations, 1 or 2 kilometer, and also trying to. So this is one paper where if you put urban region in the model and take it away. Previously, we saw that if you have aerosols, it is getting bigger and more rainfall. If you put urban, there are even more shifts to the system. This is just one study over North India. We are still, my PhD, MTech students are working on this idea over Chennai and thunderstorm. Uh, and at the same time, we also realize that these radiative interactions, for example, the crop residue burning stuff in Delhi, right? This is a image, satellite image of lidar measurements from satellite, which says where actually is the plume. So you burn something in Punjab, it is not going to be aligned with the ground and reach Delhi, right? It like a chimney, it will start dispersing. You have your Gaussian model, you see it, right? So from satellite, we can see that the plumes which we categorize two period. One, the black line is for smoky period over that region, and blue is for very clean period. When you take a difference, you see the plume is actually at 500 meter to 1 kilometer. It's not at ground. If you use the radio sound measurements of temperature and RH, you can see a very clear change in the uh, lapse rate, right? Which is actually influencing the turbulence phenomena, and the PM 2.5 or air quality over that region is deteriorating very badly. So this here also we did some simulation and tried to explain that these plumes have to be put in the model when you are forecasting PM 2.5. Otherwise, your timings will be very off. Uh, yes, some more interesting things. I am presently working with large-scale wildfires in climate models. How does Canada wildfire in the same idea? When it enters North America or goes up to Europe, is it also changing the lower boundary conditions and turbulence over the sea? Uh, Another interesting thing we are finding is in a polluted environment, the direct to diffuse radiation is changing, partitioning. If you have more aerosol, the, the amount of ratio of direct radiation coming to the amount of diffuse radiation coming is changing. And this is very important for plant physiology. Plants cannot, plants actually perform badly in direct radiation compared to diffuse radiation. If you give more diffuse radiation, their performance will change. How does this factor place? Presently, all the agricultural studies are done with climate model forecasting. But if you don't have aerosols, you don't have that process included. you are saying plants are going to be very bad, but they might not be that bad, right? So thank you for your attention, and this is my email. If you have any questions or interaction, I will be excited to talk more about it.
Parabolic thing that you said was due to dust. Is it there in the Ganga basin also?
Not that much.
But Ganga basin also has a lot of dust. Uttarakhand.
Yes. So this golden one is there. We see it is not that much, and I know why it is, because you see the dust loading is highest over the western part. This is the Indus Valley. This will be the Ganges Valley, and here a lot of anthropogenic component is there. So when I say dust, it is mostly like Thar dust,
Yes.
and anthropogenic means black carbon. So initially everyone was talking about black carbon.
You mean there's a heavier load in Western?
I'm explaining. I understood what is your confusion. So many times when we talk, we say dust or aerosol, we implicitly assume it is black carbon because that has been studied as influencing. What is new in this is it's not black carbon, but actual natural dust which is reaching there. So when we say black carbon, and if you stop everything, still the dust loading can be present there. So in central, there is a lot of black carbon loading, but in western there is a lot of dust loading. That's the difference.
Because at least from measurements, so when you go there, there's huge amount, the
Yeah.
Chardham Yatra, there's huge amount of vehicular traffic, road construction, and lot of dust goes up.
As in last year, I went there for first time, not to the western part because I was excited about that part. And when I go there, it's very different from what we see in satellite or what we imagine. So obviously, lot more measurements are needed to close this thing. And this is where the means the projections may totally change over Himalayan ecosystem because it's very sensitive. The amount, so just imagine we are talking about what is depositing on the surface. 5 times more will be present in atmosphere, and we talked a lot about atmospheric radiation, atmospheric cloud. If you put all those into it, maybe like you have still papers, cloudburst is somehow also getting linked with either radiative or these things. We don't have measurements. We have one radar in Himalayan region somewhere here in Rani Chori, which doesn't cover much. Within next 5-6 years, more knowledge will come out.
Other questions?
Yes. Because aerosol is not the only factor. In last 40 years, many other factors have changed. Chennai has grown double, right? Temperature has changed by 1.5 degree. Winds have changed, circulation has changed. The, means rainfall is a net effect of 5 or 6 big factors. Aerosol is one which we are trying to understand. That's why I intended putting it there so that some confusion arises. Many times when we discuss it, start feeling aerosol is very dominating. It's exciting because we never imagined it is so much dominant, so much impactful. But if the wind circulation changes a little, a lot of things changes, right? So we don't know yet what for example, how if you have x-axis as aerosol, y-axis as rainfall, and you change temperature of that system, how will that gradient shift? We don't know. We are still trying to figure it out because in last 20 years the temperature change is very high, and we don't have that much of long observations also. Everything started in around 2005. We are just reaching 20 years, maybe 20 more years, and those questions we will definitely know. But clear answer is the entire system is changing. It's not only aerosols.
This like this dust and all that, like I want to ask the local effect of sugar factories, lot of carbon goes, regular carbon. So it also affect that local region or
Yes. What a clear answer is yes. But I wanted to explain it more. What, as we are improving our data and computational simulation, we see a lot many processes coming out. Sometimes it like say they refer it as onion ring effect also. For I will just show you an example. Right? I had this in mind for such a question. So we just to explain how short term things can also change. We are talking about a dust layer which is present there, right? And if a dust layer is present at 4 km, it can change the turbulence and the lapse rate. Whatever is emitted here, you have a sugar factory here emitting here, it will be there, and you are exposed to that, right? What and why it is here? Because there is a dust layer on top of it or some contribution of that, right? These are like as you reduce your scale. I'm taking like if I do simulations at 500 kilometers over Chennai, there will be 10 more hotspots. Now by measuring 4 points, we are saying there are 4 hotspots. So once as we go deeper into it, putting in all things, we are still looking at a onion ring of processes and feedbacks, but very soon.
And the sensors that measure these aerosol carbon, can they be mounted on their drones?
Yes, we have been discussing, and obviously, means I also wanted to somehow say this measurement. Those short scale processes need measurement. Our instruments are very costly, so in India we don't have the suite of measurements like they have in Europe or US, and luckily we are good enough with engineering. So somehow I see that low cost things can also help a lot. The trends means quantification is always still hard in terms of modeling, but the trends and processes can come out. So and I think Indian government is also now understanding this, and lot of surface based measurement has started. Again, but what we all discussed is somewhere above the surface my work. So vertical measurements are also needed, and that also need a lot of collaborations and uh, new ideas also. So one or two papers from IITM Pune. So modelers have put in aerosol there, and they see a sensitivity of increase, but obviously we don't have measurements. Means though when the cloudburst actually happens, so satellites are not that frequent. We still are waiting for a perfect satellite overpass so that we can see this. Yes.
First is, so this all from WRF models, right? So I'm just curious, sort of curious, do you have a sense that there are some theoretical or idealized formulations or idealized even model studies which can be useful to get a better handle on these processes, or do you really need these WRF models with all kinds of different forcings? These idealized models, you think they're not very useful for this type of process, or can they be useful? Are there some situations that they can be useful?
Yes. So all this understanding started with single column models. So where you have a radio sound to initiate your single column model, you know the thermodynamic state, how much cloud is forming or how much rain is forming. Then you put out something in that model and see. That's that I think of this talk. 50 to 60% of knowledge comes directly from there. But these kind of feedbacks that I am talking to, these cannot be answered in those single models, right? So you have to club a regional scale at least so that they interact. The meteorology comes into play, right? Because meteorology is also a big thing. Single column LES models didn't have meteorology. We started with this. Now we are much more certain. What is now happening? We are running the coupled models at LES scale, right? To fine tune more. So every time, for example, if we work or do some measurement, we have an understanding. We put it in normal LES single column models. We show it, then we club it in three-dimensional models. Then we start using it at different high resolution. Periodic can also be there. Sometimes global model boundary layers, boundary information also goes into it. But many times periodic also. I have done my first paper was periodic boundary layer.
And then the other question was that we talked about this once before, but you mentioned to me that how aerosols and radiation can change the lapse rate and how it can change the inversion layer, both the location and the thickness of the inversion layer. So can you remind me of that and
Yes.
how it relates to this?
For example, this one, I'm trying to say. Here the black one is, assume a very smoky environment and blue is a very clean environment. Left side is a measure of pollution. Right side is virtual potential temperature, which can tell you about the stability of the atmosphere. Red one is the difference of both. So when you look at red one, you will see a elevated layer here, like the plume is actually present here. Corresponding to that layer, you can see the temperature is actually increasing, which should not be the case. If you are on a balloon and you start rising up, your temperature will be decreasing, right? Any day, any time, except morning period. I'm just trying to say, right? And these satellite passes are noon passes, right? So we expect it to be very unstable. The temperature should be, but we can clearly see this plume. Below that plume, there is a strong inversion. That's what I was saying on that day. So if you have this information in your model, you have this. Otherwise, you don't have that. And this actually affects the microclimate of at urban scale or very small scale turbulence. I believe. I believe that it will definitely.
So you said a couple of things. In the presence of aerosols, you said the droplet sizes are smaller and the wind shear is larger.
Droplet size is smaller, droplet concentration is larger.
You made a comment on the wind shear also.
Yes.
Are there mechanisms for this? Why are the droplet sizes smaller?
So it is like this. You have a glass of cold water, then in this room, whatever humidity is there, that will deposit on it. If you keep the humidity same and increase the number of cold glasses there, then what is condensing, that flux will decrease, and hence the droplets will get smaller because these droplets are formed on these particles as nuclei. So in that sentence, the assumption is that humidity is not changing. If everything else remains same, if you have a polluted condition, and that's a reasonable assumption because monsoon doesn't vary a lot. So the average humidity is same because of that. Really, am I clear?
And increase in wind shear?
Yeah. So that I mentioned, recently a paper has been published. What they are saying that we now understand the anvils have increased. So you imagine a lot of cloud present at 10 to 12 kilometers. So the radiation which is coming compared to a previous time, now a lot of radiation is getting reflected back from clouds at 10 to 12 kilometers. That is heating up the atmosphere and changing the wind circulation. It's fasting up. So now if you have a vertical profile, the top winds are more faster and the shear effect is coming.
Are there any other questions? Okay. If not, we'll thank Chandan once again.
Thank you. I like to talk, so thank you for giving me this opportunity.
Thank
And
you.
I believe from your faces that I could excite you a little bit on this subject. Thank you. Yes.
If you want, you can give more seminars.